Hello everyone, so in this video, it is just some sort of a theory video only. And in this video, I've encapsulated a lot of problems I have faced and I've seen, which cause a lot of problems and confusions, these terminologies. So before starting out on this series of Golang concurrency patterns, and all of those different stuffs, we have to understand some basic concepts, which will be actually asked in a lot of interviews, or maybe you have seen these terms, but you're not very clear about it. So I'll try to cover all of them one by one and try to give many more examples along the way. I've encapsulated a lot of questions. And if you want more questions like this, do hit the like button of this particular video. I'll bring out more such questions because these are the very important ones. That way I put it here in this particular single video so that you can re-revise it if you have any confusions in these particular topics. These are just simple definitions. If you want a complete dedicated video for all these topics as well, do comment down in the comment section. I will also happy to make it up. So let us don't waste any time and try to cover all these topics one by one. So the very first question, which I seen a lot of people get confused, is what is the difference between parallelism and concurrency? Now, before going down to a definition, I'll tell you with a very simple example, and then you will understand it more properly. So what you can see, parallelism. Parallelism means that they both are running parallelly. So parallelly means that, let's say if I have a two core in my laptop, if I have two cores, you have seen it like a 4 core, 8 core processor, 2 core processor, and so on. So two cores means that you can run two tasks at the same time. You can perform two tasks at the same time. Okay, that is like they are running in parallel. So that is called parallelism. But if you have two tasks, so this is like task one and task two, and you can perform now these two tasks parallelly. But now in the other case, if you have again two tasks, task one and task two, but you only have one core, now what you'll do? Now you have to concurrently at the same time, you have to either do task one or task two, but the processor is really fast, so it is like switching very fast. But it will either do task one or task two, but it will juggle around it. So you have seen the jugglers which juggles different balls. Okay. So that is what concurrency means. That you have multiple tasks, but you have only say single some given amount of resource. So you will juggle around it. I will do certain amount of tasks, let's say a certain chunk of task one, then certain chunk of task two, and so on. So I will juggle around both of these tasks and try to complete them. When you have a single resource, and if you have two different resources, then it is called parallelism. So that is the actual difference that you can learn about. You can take this as an example and memorize it and imagine it, and it's pretty much simple from the term itself, and then you can remember this example and you can remember the definitions as well. Let us look at the you can see definition. So parallelism is about doing a lot of things at once. It is doing a lot of things at once, while concurrency is about managing a lot of things at once. Okay, so that's what the difference between parallelism and concurrency. Moving forward, multitasking and multiprocessing. So these are the two terms, they are very similar to it. So multitasking and multiprocessing. So multitasking is about multiple tasks simultaneously. So as you can see, you are doing multitasking. So when you're doing multitasking and multiprocessing is very similar to parallelism. So when you're doing multi-processing, like multiple things are processing at the same time, which means that you have multiple cores and they are running and doing multiple processing, which is running in parallel. But when you have a limited amount of cores and you have a lot of work, then you are running and doing your work concurrently, and that is called multitasking. Okay, so these two terms are very related to each other. Whenever you do concurrency, you can use multitasking. Whenever you use parallelism, you can use multiprocessing. Okay, so multitasking is about executing multiple tasks simultaneously, while multiprocessing is about executing multiple process simultaneously, because it is multiple it's parallelism. It's like multiple processes are working simultaneously. It's like multiprocessing. Okay, so that is the overall these very four important terms which you will see a lot of places, but many students are not very you can say sure about these terms. So that is the crux of this. Okay, so now let us move on to the next definition. So the next definition is difference between thread and a process. Now, what is a thread and what is a process? So whenever a computer, I'll just give you a very high level example, but whenever a computer runs, it runs multiple, you can say, uh, processes. So your clock is also running here. Okay, your multiple Bluetooth is also running here. All of these are running in background. So these are different processes which are running. Now, in a single process, there are multiple, you can say, I'm giving a very high level example, but multiple sub processes. And those can be managed using threads. Okay, so let's say in a VS Code, a lot of things are working. Okay, terminal is there and everything. A lot of things maybe might working. There's a spell checker that is also working, and all of that is working in VS Code. Okay, and there is also let's say when we run this program, a particular this program will also be running. So all of them is running on different, you can say, threads. Okay, so in a process, there might be multiple threads that is like taking part in a particular bigger chunk of a process, multiple smaller threads are working. So let us talk about the definition now. So process is an instance of a computer program. A computer program that is being executed. A computer program that is executed is called a process. Now a process has three basic components: executable program, that is a program that is executable, the associated data around it. So whenever a program, sorry, a process is running, it has some data around it, like buffer space, so that like it will run. Okay, and the execution context, because it has to remember the context for which it is running. Like so if I'm running for a particular second, so what is the next second and so on. So all this data and all. A thread is a subset of a process. A subset of a process. It is a sequence of instruction that is executed concurrently with other such sequences. Okay, I have moved it somewhere. Other places that roll around. In multi-threading environment, thus sharing their process resources. As you can see, a process resources, the process is given all these things, and all of them is then fed by and used by different subset of threads, which will run concurrently on the same process, and then like actually run all of these stuffs. Okay, that is also very important concepts, like thread and a process. You can pause out, also like copy all these definitions if you want, and that's it. Okay. Now, difference between thread and a goroutine. Now, if we have a thread, now is goroutine that we will be learning about in this course, which is like spawned by Golang, like help to spawn a goroutine. What is the difference between a thread and a goroutine? Okay, why it is like goroutine is very popular in Golang. Now, a goroutine is just a function that is capable of running concurrently with other functions. Okay, pretty much simple. You cannot spawn a line like a variable declaration. Like you can like spawn a line as well. Like you can do a variable declaration concurrently as well by putting it into a function. But goroutines are just functions that are capable of running concurrently with other functions. We will go through a lot of codes in this particular series to understand like how we will spawning a different goroutines and so on. But goroutines are just functions. Okay, you can just run a function parallelly with other function calls. So in a main function, there are multiple different functions. So when you write on a main function, it has a lot of different functions that will have different tasks that we have to execute. Now, if two tasks can be run parallelly, and in the end we can combine them, so that why we should run in a sequential manner. We can run it parallelly as well. Or not, sorry, yeah, like it's parallelly. So as you can see, I am telling it parallelly, but it is concurrently. Okay, so parallelly means that we should have multiple codes, and obviously we have multiple codes, but still it is concurrently only that is being picked here. So try to use concurrently terms here, not parallelly. Sorry, my bad. Okay. Goroutines are functions or methods that are concurrently with each other running or different functions or methods. Good. Goroutines can be thought of a lightweight thread. You can think of it as a lightweight thread. It is different from thread. The cost of creating goroutine is very tiny compared to a thread, because thread is actually storing all these lot of data, all this executable data, but that much information is not required for a goroutine because it's just a simple function call. It is common for Go applications to have thousands of goroutines running concurrently. So thousands of goroutines, like you can, like if you have, I'll give you a lot of examples as well. Let's say you have seen different examples of a worker, like producer and consumer models. Okay, so there's a producer that is like us. Let's say we have some request that is coming, and for every request you are putting it in a particular queue. So there are different queue that is made. Now to consume this particular information and to do and throw some response out, there might be multiple workers or multiple consumers that is pulling from it. and all of them are running concurrently, or maybe a different cores as well, whatever you want, but it is like pulling out of this particular, you can say, queue, and working them like independently, because and that is how like multiple or thousands of things can be running out to make the overall flow very fast. Okay, a thread. Okay, this is done. Goroutines are multiplexed to a fewer number of OS threads. We'll talk about this line, which is also very important. Goroutines are multiplexed to a fewer number of OS threads. Okay, so which means that whenever you spawn a goroutine is actually multiplexed on a fewer number of OS threads. Okay, so thread, you can assume that thread which is spawned out of a process. Now on a single thread, you can spawn a multiple goroutines. You can spawn multiple goroutines. So that is why like this share. So whenever a thread is created, or OS thread is created, operating system thread is created for a particular process that is running, that has some these resources. Now these resources are shared between multiple goroutines. That is why they are very light. They don't like take all these things and run. They actually run on different OS threads and threads. So for like only few OS threads will be spawned, and all of on them thousands of goroutines can be spawned. Okay, that is why like they consume all these data from here itself. Got it. So let's there might be only one thread in a program with thousands of goroutines. Okay, that's it. Now, what is the advantage of using goroutines over threads? So goroutines are extremely economical, as you can see, when compared to threads. There are only few KBs in stack size, and the stack size can grow and shrink according to the needs of the application. Whereas in the case of threads, the stack size has to be specified and fixed. Next point, goroutines are multiplexed to a fewer number of OS threads. There might be only one thread in a program with thousands of goroutines. If one goroutine blocks, say waiting for a network connection to complete, the other goroutine is multiplexed onto the same OS thread, and the other goroutines can continue to process. Now, the first 2 points are pretty much simple. If you have any doubt in the whole thing, you can mention on the comment box. I would love to reply to all of them. But let's talk about this one. The last one is, I think, so a little bit difficult to understand. So what we have learned is that on a single OS thread, multiple Go routines can be spawned. So you can assume that you have some table, okay, and multiple goroutines are like working on that particular table. So you have a single table, and multiple goroutines are like working on this table. Okay. Now goroutine actually has a scheduler that will pick, like, sorry, not goroutine, an OS. This OS thread has a scheduler, like there's a scheduler actually that will pick out which process to run, and from that which process, which actually thread is being run, and then from which thread which goroutine has to be picked. So it has to somehow pick among all those thousands and like you can say hundreds of goroutines, which one to pick and to actually run on this particular core that we have to complete the task. So it has been switching very fast and so on. So now which one to pick has to be done very economically and very fast as well. Now let's say one of the goroutines is running concurrently and is waiting on a network call. So let's say I spawned two goroutines. One goroutine is doing some work, and the other one is waiting for a, like, it has done some HTTP call and waiting for the response back, and then it will do some work. Now this is waiting actually. If this is waiting, why should I actually spawn it again and do some work? Because it is like waiting. It will not do any work before it gets the response. So the oral scheduler, or it has the capability, because it is running on the same OS thread. It is running on the same OS thread. It is not using any more resources, extra resources. Why? Because it is running on the same OS thread. This is waiting, so it is like kept here. The other one can use the resources again and again, and the scheduler will also schedule this before this will eventually get some response and then process the work. This will get more advantage and more things to use more resources on the same OS thread, and you can say and work. Okay, so that is the benefit. Why? Because we are using less resources and multiple things are waiting on the same OS thread. If it get wait, it doesn't block the resources because the other resources can be used by other goroutines as well. Okay, that's the overall thing. Let's talk about the same line again. So if one goroutine blocks on waiting network connection to complete, then other goroutine is multiplex. Multiplex is that it is now given the more priority in chance on the same OS thread so that the other goroutines can continue to progress. Okay. Now, what are coroutines? There's goroutines. Goroutines also concept. It might be asked in some interviews, so that's why I put it here. Goroutines are computer program components that generally subroutines for non-primitive multitasking by allowing executing to be resumed and suspended. And you can see here that if coroutines are well suited for implementing familiar programs components such as cooperative tasks, exceptions, event loops. So core routines you can say are different also, like these are also like routines as well, but it is like running and waiting for different event loops, iterators, event lists and pipes. Okay, now let's say we are running some program, like these are internal, so these are spawned by you, these are internal, which is like how the actual scheduler is waiting for it, like they might be also waiting for some task. So these are core routines. Okay, you can also read it online. I just put in the definition so that you know about this term and you can read it online as well. If you still that out, you can be mentioned in the comment box. And multiplexing, I've told you, multiplexing is a set of techniques that would make it possible for multiple users to share a single resource concurrently. So we have a single OS set, and these are the techniques, multiplexing are techniques so that multiple routines can share a single OS set. Multiplexing in the context of concurrent programming, especially in Go, involves efficient managing multiple resources or tasks or stream of data by interleaving the execution or processing of a shared resource. So I've told you definition, you can go around it, and I've told you the concept as well so that it will become very easy for you to understand, such as operating system threads or maximizing throughput and responsiveness. And what is scheduler? Scheduler is a primitive scheduler if it has the ability to forcibly remove operations from a CPU or a core. So scheduler actually gives a chance to these different OS threads to run, which one to run, and then eventually which coroutines we will be running on that. And it has the ability to put a process from a CPU like to a CPU or from the CPU core, so that like it is actually giving these processes chance, so that a process gets chance and then eventually it's the OS thread will get a chance and eventually the Go routine will get a chance. So like because we have single resources, we have a fixed amount of resources, we have fixed amount of code. So a scheduler has to schedule a given amount of time on the cores. So core is actually, you can assume that you have fixed amount of gas stoves in your house. Okay, and there are 10 people that want to make food on it. So eventually, let's say for 1 hour, one person will make food, another half an hour, another person will make food. So it has to like a fixed amount of resources. So a lot of people have to cook food and process output. So a scheduler will actually let all these processes given chance one by one to actually do the process one by one. So these are different definitions. You can pause out and try to read it again. If you still haven't out, you mention in the comment box for this particular video. Stay tuned all this series. I have given you a lot of concepts and we will go through a lot of codes, all the different concepts in Goroutine concurrency. That so that because a lot of interviews are actually asking all of these terms and a lot of folks doesn't know about this term. So I thought to make a different dedicated series around it. So if you still have any doubts, you can mention it in the comment box for this particular video. I'll see you in the next one. Till again, coding and bye.